dans les exigences. Donc, là, ce n'est pas.
So hopefully it's okay. So there we go. So now the microphone is on, so you should.
Very good. So this.
À distance,
I don't think
Washington,
Yeah. The only thing is I won't be able to monitor the Zoom, or I'm gonna try to sign in on my phone. So in case someone chats, like you might get a pop-up from the chat because I don't have that. But I'll try to sign in on my phone so that
If I see anything, I accept.
Okay, yeah, sure.
Hey, good afternoon, everyone. Je vais parler en anglais cette fois parce que mon français, je dois améliorer beaucoup pour faire ce type de présentation. So I'll start in English right away. So thank you all for coming. I'm very pleased to see so many of you here and interested in the talk. And many of you also over Zoom. I see there's quite a few like friendly faces I see there.
Say hi to Stan.
Say that to Stan. Yeah, hi Stan. I hope you stay for the long run because we talk about your work at the end.
Hi Diego, how are you? Yeah, we're getting into
I plan like half an hour. Maybe I can do that. So for some of you that don't know me, I see many new faces as well. Just gonna give you, a run of where I've been. So I've been around for a few. I'm from Brazil, but I did my bachelor and master's. I work in the industry there at the time for developing the solutions for the stock trade market. Very exciting times back in the day until the market broke, and then I decided to study a bit more, right? So I did my PhD in Germany in Heidelberg University, and I've been in Montreal. Actually, I realized when doing the presentations, almost 5 years now. So I started as a postdoc at Concordia. Then I became a professor at UConn, right? Where I taught one of the courses I will be talking about today. And last August, I joined Concordia as assistant professor. And I'm still holding a position of adjunct professor at UConn, where I'm very pleased that the department is welcoming me with open arms after all of this. Still. Well, okay, so my research is on like 3 main pillars. I'll talk about AI and software engineering a little bit today, but I work in dependency management, like trying to help software and help developers in reusing code, right? So we use libraries for everything. We have to maintain them over time as well. How to ensure our systems are responsive, a lot of work in performance engineering and ensure that they can capture performance regressions over time, especially with databases and large-scale systems. And more recently, I'm kind of dabbing into, how do we engineer reliable AI systems, right? And that's my focus of the talk today. I'll be focusing a lot on the 2 courses that this one I co-created and this one I'm offering right now. It's very recent. Both of them are quite new. I kind of have a hidden agenda here to sort of boost the interest in engineering AI systems. So we have people that can actually do this course at UConn again. I did that in the past. All materials are available and so on and so forth. And now I'm kind of dabbing with Gen AI and software engineering. And I tell you, it's a nightmare, right? It's a lot to learn. There's a lot of new papers coming out every day. It's giving me a lot of work to sort of piece it all together. And I will be sprinkling, some LLM problems here and there in the talk today, so you know the nightmare that is to upkeep and maintain those systems as well. Okay, so although I call, software engineering for AI systems challenges and research opportunities, these are kind of my rambling thoughts, right? That's what keeps me up at night on a rainy day, on a Tuesday, thinking about those problems. They're not actually super well structured, as it should be, as in the course I kind of pinpoint the ones that I found to be the most interesting personally, and also I think it'd be interesting that maybe you can tackle as a researcher or as an educator, right? So I will start with a sort of a definition. I just want to sort of put everyone on the same page. What do I mean by AI-based systems, right? This is any system that has 1 or more AI components. They could go to, the self-driving cars, but also your traditional software system that the manager just thought it was a good idea to add an LLM to talk to customers, right? That now become a system that is subject to all of the forces and laws of AI as well. So we're talking about statistical learning, machine learning, deep learning. So even though most simple models, like data-driven models, they can create all sorts of challenges for your system maintenance. Right, and we've seen this over and over again here, like 3 examples of failures of AI systems, right? The most, of course, dire when you have self-driving cars crashing. Very recently, there was a report that saying the Tesla cars turned out to be one of the most, of the highest risks of accidents because drivers are reliant more on the self-driving mechanism, which is, it has its flaws, right? But we also have other problems with, like Amazon tried to solve the hiring overload, like, so they get too many CVs to analyze. They thought it was a good idea to build a model, an AI model to rank the CVs using certain characteristics, right? And they were actually quite careful at first to omit anything related to identity, to race, to gender. But turns out the model was still finding like keywords and activities of the CVs that were biased against women, for instance. So the CV would not look at the gender, but if he found, oh, this woman chess club participation, he would actually rank that CV lower than other CVs, right? So they had to dish that out completely. In Twitter, not so recently, but it's also an interesting case where they had a thumbnail zoom. So if you submit a large image to Twitter, to build a thumbnail, this was done automatically. So a computer vision algorithm would just zoom in one person's to build the thumbnail. And they found out that the zooming would only happen to white people, right? So anyone that has a darker, complex skin would not be considered as part of the thumbnail for that image. And they had also sort of scrapped this kind of algorithm as well. And perhaps one that I want to exemplify why engineering and software engineering could help is the case of Genderify. So Genderify is a system, and by the name, you can already think of it. It's quite problematic to even think about this. But the idea is that you would submit names of customers to identify their gender and then write proper emails to greet them in languages in which gender are sensitive, right? And at first, you start seeing like the most common biases you would find out. So if you put scientists, you'd see male, 95% of male and 4% of female, but very biased. Even though this is not a name, they should have thought about this as a system that maybe it wouldn't allow to submit anything but names, but they didn't think of that. Even worse, if you go like with some weird, so stupid, you start grading higher female than male. Right? It's a problematic thing. And it got to the point it's so ridiculous that if you were to ask for a woman, it's 96% chance of being male. Right? So these are cases in which we know quite well in certain aspects, certain process of software engineering, that, if you do some better definition of requirement, if you test things, you do A/B testing, you test for biases, or even have proper data requirements or system requirements, maybe they shouldn't allow people to submit anything but names to their system, right? This could help, of course, alleviate the problems that they faced. And perhaps one thing I want you to take out of my talk, if you have to choose one thing, is that, we focus a lot on the sort of the ML pipeline because it's easy to consider that as a teaching component, right? So we have a machine learning course, AI course, in which we teach students from collecting the data, processing the data, future engineering, testing the model, training the model, and then outputting a prediction of performance. And that is the ML pipeline, and that's complex on its own, right? There's all sorts of moving components to have a reasonable trained ML model. The thing is that when you think about a system, the ML pipeline is one, but a small component on a large scale of a system, right? We have components that about system configuration, data collection, machine resource management, serving infrastructure, monitoring, analysis tools. All of this go into what we call an AI system. So the model pipeline, the training pipeline, it's a small component of a much larger system, right? And the point I'm trying to make here is that the quality of that system depends way more than the quality of the model that was being trained once. We need to retrain the model to capture changes in the data. We need to have resource management. We need to have strong monitoring infrastructure to ensure that the system that we train, system that we deploy, have similar qualities, right? And we've seen over and over this, like This is Greg Brockman at the time, 2022, right? So thinking about, oh, maybe you should consider a bug tracker when you're talking about ML systems. Just something we've learned long ago in traditional software systems how to handle, right? But because we have this difference between software engineers and data scientists, very often they don't speak the same language. And my point here is that they need to communicate the same language, or they need to be trained to understand each other if you want to develop reliable AI systems. Perhaps one final piece of motivation. This was a work I did back in the day and before chatbot was cool, right? This was before ChatGPT. Went with an undirected study where we looked at Stack Overflow posts to see, you know, what are people developing chatbots asking about? What are the challenges that they're facing? And as you expect, there's a lot there is related to AI, right? Model testing, conversation, intents and entities, so NLU integrations loss in the natural language understanding unit. But there's also, so I messed up the animation, but there's also a lot of traditional software challenges. How to integrate frameworks, how to develop user interface, or how to parse chatbot responses. Right, so those were the topics we found, and the right sort of quadrant is the most difficult, although arguably they have very similar difficulties over time to answer questions related to each of those topics. Okay, so there goes my motivation. So can software engineering ensure that we deploy reliable AI systems, right? And the question is, well, not necessarily, right? It is, because it's a MacBook. So if you have a Windows error there, that would be mind-blowing, right? But, well, no, like Windows is one of the most well-engineering software products we have, and we still have errors on it. But my point is that if you apply certain software engineering practices, or if you try to, emulate the successes of software engineering community, like we have software products that are being released many times a day, right? They have everything automated, continuous integration, testing, and they release 50 versions a day. Like if you take MMO games, right? Massive multiplayer online games, they release versions every hour or so, right? Catering to some particular user base. And if you're old enough to know Java updates, you know that Java used to update 3 times a day. Right? You'd always be asking for updates. I think they changed it now. Right? So I have 2 things to talk about today, 2 areas of work where I found that my research in traditional software engineering wouldn't quite apply to AI systems, and where I think there's a lot of challenges we need to tackle. And they're related with design and requirements. Rather, it's only requirements. I think I didn't include too many things on design and maintenance, right, which is on the right side. So we'll start with requirements and design issues that we face in AI systems. So the way I organize this, on the left side, whenever I'm comparing 2 things, this is the traditional software system, and that is the AI-based software system. And usually, AI-based software system has all the complexities of the traditional software system, plus a few extra things. Right? And that's what I'm going to draw the attention towards. So let's talk about system requirements, which is, I know it's not everybody's cup of tea when it comes to software engineering, but there's a lot of reflections to be made there, right? First of all, I mean, it's quite evident that system behavior in traditional software systems are determined by the client, by the analyst that comes to you and says, I want to automate this process, right? That's something I've been doing for many years. This is the process that I know of. And maybe after the process starts being automated, the requirements keep changing, right? Requirement engineering, it's a fluid thing. System behavior in an AI system is very much learned by the data, right? And that's where a lot of the problems will come from. It's like someone comes to you and say, I don't know how the system should work, but I have a lot of data from past systems or curated data from not even automated systems, right? And they want you to use that data to develop behavior in the software. And usually when you think about functional requirements, traditional software systems, we have a huge list because everything is specified. Features of your system and things of the sorts. But functional requirements for AI system is very blurry. right? Because we don't know how the system would look like before we start training the models. We know maybe that you want to predict the risk of a credit, let's say, credit request. Like if you, that's one area in which this AI is applied a lot, the credit score. And if you want to get a loan in the bank, there's a lot of models there. And the idea for that is, of course, I want to reduce the risks that the client will default, will not pay back the bank. But you don't actually know how this would happen. Do you know that you have enough data that you think the model would be accurate enough? And by the way, I will be talking about many different things. So if you have questions, and that's also for the chat, I'd rather have you ask immediately so we have the discussion. Otherwise, you will forget. I will move on to a different thing, right? So I see that Rafael had a face that has a question there. Go ahead.
Two issues.
Mhm.
So if you define AI system as a system that includes an AI component, so what you were saying here actually applies only to the AI component.
Yeah, that's it. So this is always extra things, right? So AI systems have all the complexity of a traditional plus what comes with the AI component for sure.
So even that being said, I still hesitate to say that the system behavior is learned by data. I mean, you mentioned the example of AI systems being used with, for example, credit scoring and stuff. So first, AI systems, there is more than machine learning.
True.
There are the rule-based systems. And I'm familiar with rule-based systems for credit scoring and so stuff like that. So it's a little bit more complicated. So
True. And I'm here catering a lot to ML as well, right? Because that's where
the functional requirements would be like to enforce a company policy which says don't underwrite customers who have a high risk of default.
Right.
So and that would, I mean, that would be a requirement regardless of which technology you use, whether you encode it in Java with if then else.
That's it.
Or with the rules or with data. And actually, the data just gives you the thresholds that you typically put in the rules. So
right.
The bank could tell you, okay, we observe that anybody with a credit score of less than 650 has a high risk of default. So you implement that in a rule that says if credit score is less than 650, reject.
Right.
That's why I'm saying it's a little bit more complicated.
Yeah. Well, of course, you can dive in and I'm catering a lot
about SPAs. So
that's true.
For that one particular kind of problem, this is true. So what you're saying actually applies to what I presented 2 weeks ago, but not to systems in general.
Right. And I mean, if you can always derive rules, I think a lot of the problems here would not occur in a system that have well-defined rules, even if the rules come from the data, but then they become specifications again. Right? They don't. So that's kind of the good side of using very like interpretable AI, right? Things that you can understand fully and derive rules from it. And some of the problems I will be showing here comes more from this sort of black box models that are trained on large amounts of data that you don't fully understand how it works. But absolutely, I agree with you. But yeah, so in terms of functional requirements of the model, that's where I think things get a bit fuzzy because you want to have accurate prediction, right? And you want to reduce the risk. You want to have maybe a requirement that says, we are hoping to achieve only 10% of default, 10% of the clients that don't actually pay back.
And if I may, sometimes you also you don't care about individual prediction. You evaluate system based on KPIs. So you say, and that's actually used in testing. So we develop a system that does mortgage underwriting, and then you say, here is 100,000 records, historical applications. The system should reject 30% of those.
True. And just to be clear, right, I'm not talking like very loosely on the requirement side, more about the behavior, who you decide to reject, right? That, of course, if it's a pure ML system, that's not something that comes with a specification very easily, right? It comes from the data. But yeah, that's absolutely the case. And you have always different types of AIs, right? And I'm catering more to the machine learning, deep learning kind of thing here. On the other side, when you talk about non-functional requirements, and you have enough for the traditional software systems, you have even more when you talk about, AI systems, right? Because on those data-driven components, you have the risks of unfair behavior. You have problems of equity. You have problems of transparency and opacity, in which not even the ones servicing the system understand how it works the line, right? They have a model, and the model is a black box. They have an issue of explicability, which we'll talk quite a little bit afterwards. And of course, data requirements. There's a huge list of new sort of requirements that come from AI system. Yeah.
How about maintainability?
Yeah, well, this is not comprehensive, right? But both of them would have that. And just to reemphasize that this is just added complexity to the ones over here, right? Yeah, maintainability, we have, compliance to regulation, right? There's all sorts of non-functional requirements. I'll be focusing on some of few today, right? First one, how to define equity, or how to ensure the transparency of a system, and how to ensure decisions are explained, right? And I will talk a little bit about that, the challenges I faced when I was doing research on the topic or preparing for the courses, right? And one thing we found, yeah?
I'm not trying to give you a hard time, but I'm trying. If you go back to the previous slide.
Yeah.
Equity is also a requirement. It's a regulatory requirement.
True.
For non-machine learning based system. Except that if you develop your mortgage underwriting application in Java, or using business rules that people can read, an auditor can actually look and say, there's no bias here, whereas with the black box, they can.
True.
So it's not the case that equity is not the requirement in the other case. It is always a requirement, and it's regulated. Whether it's insurance, banking.
True. Fairness the same, right? It is the same.
Right. Except in one case, it's easy to audit, in the other case, it's not.
True. I agree with that. So maybe I should. Oh, there's a question also there.
Yes.
Oh, you're having a hard time understanding Afed. I think it's just that he's a bit, so I'll try to repeat the question, right? Or the positions that Afed is making, because he's a bit far away from the mic.
Yeah, and also I have a question for
Afed's
you.
point is that, of course, we do need, equity, and there to many degrees, all of this applies to traditional systems, but some of them are given by the way we build traditional systems. So explicability and understandability that comes with, of course, ensuring that the code that we develop is understandable. But when it comes to machine learning models, black box models, that becomes a challenge on its own, right? I'm not sure if I'm making myself understand.
Laurent works for an insurance company, so.
Huh?
Actually, I do have another question. Sorry.
Laurent, do you wanna add anything? Because I only saw your comment.
Yeah. What do you make of one of the main? Can you hear me?
Yeah, now I can.
Okay. What do you make of one of the main issue, if not the main, the most challenging issue when deploying AI application in real in the industry, which is how to break the frontier barrier between prod and non-prod environment? Because as a former AI architect, I can tell you that probably 60% of my time was dealing with moving data models, etc., between prod and non-prod environment, when in the industry there is a strict separation between both.
So I didn't quite get a prod and not prod. What do you mean by that?
The difference between the production environments where you have real data and non-prod environment. And traditionally, there is a strict separation. Developers have only access to non-prod environment, so they don't have access to real data. But you're dealing with AI system, you have to move data from one place to another, and security rules definitely prevent that.
Absolutely. So I'll touch on these points in two parts of the talk. One is on the operation part, right, in which we have a big challenge in combining the traditional DevOps, DevSecOps with data ops, which is I think what you're saying, like managing data, transferring data across environments. And I will touch on it in a few slides, also on the data requirement part. So I know that, for instance, there is a lot of course, regulation in terms of data. So I'll talk about a little bit on this, also with LLM models. So maybe I can better answer some of your questions once I get there. But my experience, this has been, as you mentioned, a big issue, mostly in terms of also there's this huge New York Times lawsuit with OpenAI, also in terms of data copyright issues, right? That's it's on particularly every newspaper. So there are a few points I will touch, but I will not maybe dive into too much detail. I'm sure, like Loha, you can, at the point, you can actually raise and talk, mention to me like the points that you actually face. It would be very nice to have the exchange. Does that make sense?
Yeah, definitely.
Thank you. Thank you.
Thank you.
Okay, so passing that of the definitions, one thing for sure we're dealing is the big problem of unfair behavior of AI systems. Right, and this is a social technical problem that we can spend, our entire lifetime thinking about. What is fairness? I remember Ian sent me a nice YouTube video, even with the provocative idea that AI systems cannot even be fair to begin with, which I sort of agree, right? But thinking about that those systems are between us and among us, we have all sorts of issues, and even if you go beyond, well, we have a well-defined fairness quality for our system that we aim to achieve. You work with sociologists, you work with anyone working in the domain, in the industry, and you find there's the kind of fairness we are aiming to achieve for the system, which means you want to treat treat groups of user base in a certain way. There is quite a lot from the technical side that it's challenging, even after the definition, right? So here I'm showing you, it's a paper from Team Menzies that shows at least more than 20 metrics for defining different kinds of fairness among groups that you will need to, as a requirement engineer, as a fairness specialist, perhaps, have to cater to this. And once you have defined the metrics you want your system to optimize towards, you still have, more than 20 methods to choose from with hyperparameters, not on the top of your already complex machine learning pipeline. Right, and one study we did back a few years back is that maybe we could combine them in a clever way to sort of have the best of both worlds on different sort of fairness methods. And our answer is that it doesn't work. Combining different strategies did not yield any of the better results in terms of fairness metrics, and we're in desperate need of social engineering process to handle this. So far, this is one of the major challenges of AI systems, is that from the social perspective is a challenge, but once you go past that, engineers have a hard time fine-tuning and finding what could be the best model and techniques to apply. Yeah.
Also, I like that you use the social engineering. Because sometimes you want to go beyond service.
Yeah.
You may want to implement affirmative action policies to compensate for historical.
Yeah.
So actually, sometimes you may need the system to be biased in a positive way.
Yeah. And by the way, like fairness metrics, they accommodate this.
Okay.
Right. So when you say fairness, we mean actions that make our model less biased towards the type of bias we don't want our system to have. But that, of course, means sometimes adding certain bias that are desirable, right, from minorities or things of the sort, for sure.
Right now, it's fashionable for everybody to criticize all of the biases, etc. If you look at what's happening in the US, where there are historical disadvantages to, for example, Black people, and soi-disant those who ask for fairness want to get rid of all of the affirmative action policies.
Right.
So sous l'enveloppe de fairness, and that is actually.
It's tainted, right? It's already kind of, it's a, absolutely. So this is for sure one of the biggest points, yeah?
Socio-engineering, has this been defined? Like, software engineering first appeared on the planet late 60s, and we've been still defining it since then.
That's a good point. I don't think it has been defined. This is kind of my phrase in, because I don't want to only say this is a technical issue. I think it's requires EDI qualities in the system. It requires, you know, all thoughts of, and the process should combine both. Yeah.
But that would be a good research topic to define what socio-engineering and AI system would mean.
That's it. It could be for sure. And one thing we noticed, so we have a master student working on this, and we're trying to, you know, explore several different methods, and it's a bit all over the place, right? It's a very difficult process to engineer your system for you know, fine-tuning your model for certain metrics. It requires you. We kind of have the same phase in which early 2000s we were kind of trying many different models, ML models, and nowadays everyone uses random forest, logistic regression, and some deep learning. At that point, we are, you know, having many options to choose from. It's a daunting process to go through this. The second point is explainability. So you see, I'm going very shallow on each of the points, so sort of give an idea. Explainability, for those who don't know what it is. So usually when you have a black box model, a deep learning model, an LLM model, and you try to explain what the model is doing or predicting, you actually need to develop yet another model, right? That sort of tries to simplify the space of your deep learning, deep neural network, for instance. And there are many approaches like this. LIME is one of the most famous. The idea here is that you get the big model, which you cannot fully comprehend, but then you try sending input and output to sort of understand the space of decision of the model. And of course, explainable models are always wrong. They cannot be as complex as the black box ones, right? So it made a huge, there's all sorts of risks in applying this. And there is another chain of thought that says, okay, we should start using more interpretable MLs, which is, yeah?
J'essaie juste d'alimenter la discussion.
Yeah.
C'est important d'écouter. An ex-postdoc of Sebastian Gams, who's now a professor at l'ETS, he actually worked on the explainable models, and he showed that you can actually you can lie about the fairness of an explainable model. So you can, for one black box model, you can find several explainable models that have the same performance characteristics, but you can hide the bias that are in some of these models.
That's it.
So that's not that. So the fact that it's explainable doesn't mean it's.
And you're making the point for me, because that's what I want to arrive, right? So the explainable model is the solution for helping to explain black box models. But I think the point I actually want to try to make is that even though you can explain some things, you can make all sorts of explanation that comprise with the same black box model. Here is one of the cases in which, in the article, they found that they were using a black box model to decide whether inmates would receive a parole, right? And because black box models lack transparency and accountability, because you don't know actually what are the rules that decided on each. So this was a very famous case in which the inmate was denied. He had to remain in prison and had to fight for his right to receive the parole by challenging the system, a system that not even the government knew how it worked. It's a famous COMPASS system. It's a case study in the problems of having those black box models in high-stake decisions which can change people's lives, right? And this paper, you know, it's a very influential paper. I think it has maybe like 10,000 citations by now. Cynthia was actually pushing for the need for more interpretable models, that explainable models are not enough. That if you use a black box, use deep learning, you're never fully sure of the rules the model develops by learning the data. And that means the explainable models may not be faithful or informative enough and lead to overcomplicated decision path, especially if you're deciding someone's life, someone's career, right? Dependable models, on the other hand, much easier to debug and evolve. And here I wanted to cater to the software engineering thinking of like evolving a system, right? We always need to debug a system when we implementing new features, testing it, and interpretable models allow you to do that, while explainable models and black box models don't. And the only downside, and I think that's where the industry is leading towards, interpretable models are very hard to protect intellectual property, right? Because models become rules. Rules can be copied, while your black box model that's hidden in the server room becomes a solution that is patented and can be used, right? So very influential paper. It's a very interesting study on this. And what I find to be very challenging is that we are moving away from explainability in AI development, right? So you see here on the left side, no models are becoming larger and larger with the LLMs. That means they become more opaque, harder to understand, and they're becoming over time more and more. It's more frequent to see closed models developed in the industry, right? In which you have no control on how it works, right? So my point here is really we need to move towards developing techniques that can allow us to have interpretable models with similar qualities than what is being hyped in the industry for as a black box and deep learning models. Okay, so especially in cases where there's high-stake decisions to be made. Okay, that was the point I wanted to make in explainability. Finally, in terms of requirements, I'll talk about a little bit about the data requirements, the things that I've seen having a huge impact. I think if you're not familiar with this, it's data scientists spend more than half their time with data, just collecting data, processing data, transforming data, extracting as much information from the data as possible. Which means, of course, that's something we pay a lot of attention to. And there is, I think, what Lohan was mentioned, one of the things they're having pushed forward, especially by the European Union's regulation on what kind of data can be collected. Here it comes a huge challenge, right? Because most of the time, companies collect as much data as possible and then decide what to use later. Especially for a perspective of someone designing a machine learning model, you don't know what features would impact your model at the end. You just collect as much data, you then do feature engineering, then you remove what's not useful, you keep what is useful to you, right? But the GDPR says that if the data is collected but not for specific use, it cannot be collected, right? So that became huge challenge in traceability and data, and what are the data that's collecting forums that actually are warranted to be collected versus what the companies are just collecting just in case. And I think if you don't want to get the monopoly card for go to jail, that's something you need to really be on top of your game. So let me see. Right, Lohan even added like more than 50% of the times waiting to get approval to access the data. And that's absolutely true. Another point is, especially talking about the large language models, how much data do you need? That's something I was preparing for a class a few weeks ago. And the large language models, they're basically getting as much data as they can. And that is kind of causing one of the most important lawsuits in terms of data and AI today, which is the New York Times lawsuit against OpenAI, which they are claiming that not only the millions of articles have been used, but that OpenAI has tuned their model to give higher weights to New York Times paper documents. That means they have to filter for data quality. And the common way to do that is to actually have rule-based models to weighting reputable sources and putting them as a higher priority for the model to learn. Okay, and large language models are basically crawling everything they can. And you can see this, the size of the data sets they're commonly used. We are very much going to the terabytes of data because for a larger model to be achievable for getting the performance they hope for, they need even more data. So now we are at the weird spot in which data curation is kind of second worry for those LLM systems. They actually need more and more data all the time. And if you were to think about regulations and how those models are actually working, most of the LLMs that we have today, even from reputable sources, would not pass the new EU Act for data quality, right? Data governance, copyright data. You can see here, copyright data is definitely one that only Bloom is actually doing something about it. Most of the models are using copyright data without any distinction, okay? So here we need, data traceability. We need, for AI systems, we need ways and tooling to be able to map the data that we're using for training to make sure that the evaluations and testing are done in a proper way, okay? I know it's been a bit scattered, but just going back to the system requirements that I wanted to explore, the differences of traditional and AI systems, we have to worry way more about fairness if you're talking about AI systems, because you don't control that with specifications that emerges from the data. There's a problem of transparency, which even the best engineer in your team will not know exactly why the system made the decision that it did. And you have all sorts of data requirements, which Laurent was very nice to mention his point of view. I think, Laurent, if you want to say anything for the discussion, but I think that's what I had to say about it. Very much a surface level, so I believe you can give some more detailed experience.
Yeah, again, in most at least large organizations, there is two completely different world, prod and non-prod, not the same people involved, not the same networks, not the same rules, etc. And I will say moving data from one environment to another, it's not really the big issue. It's more like where to put all of the pieces, like let's say MLflow, which is the de facto standard in storing models. Do you put MLflow within the prod environment, then you cannot use the models to do some testing, or do you put it into non-prod prod, and then you cannot have access to it when you run your models? And yeah, it can become really tricky. So I don't think that if you build any like CI/CD pipeline for data, for artifacts, etc., if you don't consider those completely different worlds, your approach will not work, because you cannot apply it in the real world.
Right, and so for those that are really back there and I want to hear what Laurent said, and I fully agree. I mean, the differences of environment between development and production are some stark contrasts. And I have a slide on this, on the different kind of operation pipelines that you have to construct. Sometimes you don't even own all the pipelines. Sometimes you have another company doing the ML ops for you, right? And doing things, and so integrating this is a huge challenge. So this is the end of the first part of the requirements. This kind of me diving into an area that I'm not the expert on, and that's, I think, was well mentioned by Afed. I'll dive into the maintenance now with a bit closer to the to my area of expertise and the things that I've seen, like dire problems of AI systems. But any questions about the first part so far? Very good. I'm not sure if I'm too late. So we'll talk about maintenance and evolution. It's going to be, some themes I want to touch. Of course, on the traditional software side, we have one of the biggest problems is dependency management, because you build your system by reusing as many libraries as is, I wouldn't say possible because that's too much, but you use as many as it gives value to a product, right? And that means you have to have strong processes for building the software build of materials. You need to deal with security vulnerabilities that come from the dependencies you use, from the open source code you use. And there's all sorts of practices that we have perfected over time, which is not, it's not perfect, but it does work, does give us a large confidence that our release is coming out 10 times a day, coming out with quality. On the side of AI, right, we had a problem of model management and how this is still it needs a lot of development, right? And that's really the point I want to make, is that all of those challenges, they can be research topics, they can be application topics that some of you might be able to solve some of the problems I'm mentioning here. We now have security vulnerabilities for especially the large language models. They're coming out very recently, documented. And we have the big problem of operations. How do you keep retraining the model automatically if new data comes in to find whether the data and the concepts that your machine learning models learning have drifted or not, right? So essentially, what I mentioned before, like the way we develop software, it looks way more like on the right side, where we getting building blocks, libraries, and putting each other and gluing with code over business rules, than it used to be where you had to develop things from the scratch, right? And one thing that, so that's the paper that I published with Afed and Stan, which I hope it's still there. Hi, Stan. This was one of the industrial cases that I faced first that were a company, large company, there is now implementing a process to build the software bill of materials of their products. Now you think of it, you know, software bill of materials is like the set of ingredients that your product contains. It's a very important piece of information. It was very hard, and it is very hard for companies to do that because they have been using open source unregulated for many, many years, right? And one thing I want to mention, once we started looking at that, this is Stan's doing the work and telling us, you know, what he was finding. One thing that kind of struck to me is that their product catalog would use 18 different libraries for XML parsers, right? All different things doing almost the same thing, but different libraries. And you could clearly see that sometimes we'd have the Jackson data format and 13 different versions in which 3 of them were vulnerable. And that is everywhere in the industry, right? So we have another partnership with a company, large company, that only after the Log4j incident, they started worrying, okay, now we need to catalog all the open source code we use. Because if new vulnerability comes down the road, we need to know what are our products that are affected. So that is similar to AI systems, but AI systems, we already have standards for data components that are supposed to give all the information of the data version and data that was used to train. But this is really not, first of all, it's not enforced. And we need a lot of tools to ensure the traceability, right? So Lohan mentioned the MLflow. MLflow is a very good tool for tracing model versions and even some data versions if you combine it with the DVS or tools of the sorts. But there is a part and that we very much in the infancy. Right now, ML models, they don't come with all the requirements, all the data they used to train. They don't come with all the technologies that they were meant to use. Yes?
SPDX.
I forgot the term. And I was kind of finding this protocol was kind of very recent. Oh, okay. So software package data exchange.
That's all
Yeah. Going back. So we need all sorts of tooling to trace data, to trace model versions. We're kind of, as we're going, like there's a lot of research that needs to be done there. It stopped working, so let me just click here. Right, the second one is dependency management. Like on the traditional side of things are not super great, right? We have semantic versioning, we have all sorts of processes, and still we don't manage software dependency management as we should, right? We don't manage our dependencies as we should. And we did a study back in the day, and we found 80% of open source projects had harmful dependency management practices. I mean, they would input the URL of the package in their package.json, or they would not update that as they should. And many of the reasons is that they're breaking changes and lack of trust in the ecosystem. So this is the traditional software, right? However, in the traditional software, we are developing all sorts of approaches to help developers maintain their dependencies. So things are moving progressively to the better. So we have practices and protocols. So semantic versioning is meant to help you update your libraries and update to the version that will not break your code. At the same time, we studied Dependabot and found that automated tools can help a lot the developers at updating their dependencies over time. The same is not quite true for managing models in the ML world or the AI world, right? So this is a very recent paper that looked at how open source projects using pre-trained models in their code. And you can add a new model to your code by just adding a line like this, like from pre-trained, and you add the name, the ID of the model. No versioning, no backwards compatibility worrisome, like it's is as raw as it could be, right? So you have problems of what is even a model version? Can a model be backwards compatible? Like if you generate a new model from new data, can you even deploy that in your product that was tested with the previous model, or do you need to do it all over again, right? Breaking changes and automated updates. How do we even have automated updates if every new model that we download is a completely new beast, right? They do not output the same things, right? There is a motto in AI, which is change anything, changes everything. So every single thing that's changed may impact your model, and your next release of a product that uses that model may break, okay? So all sorts of challenges on this particular front. Yep.
Just to add a bit of information around this. So I'll take the example of insurance.
Mm-hmm.
So a company can have some underwriting rules, which are somebody applies for an insurance product, whether you accept them or not.
Mm-hmm.
For some business applications, for example, you're audited by a regulator. So even though you may have changed your model, and here I'm talking regardless of whether it's rule-based or whether it's machine learning-based. So even though you may have changed your model, you may need to rerun, to go back in time and rerun applications that were submitted, say 2 years ago,
Before, right?
with the model that was in effect 2 years ago.
Right. Right. So,
Yeah, you do need to keep those versions available and usable for all sorts of reasons, including regulatory.
right. So, yeah, this is a great point. And I think overall, I'm not sure if that in the next slide, yeah, I have an example of what does it mean to have model management in the large language models world, right? You have here Llama 2 is one of the best engineering open source models from Meta. And there is nothing to allude to a version except for the 2, right? But you have different model sizes, you have different model formats, you have different model fine-tuned. Some of them are fine-tuned to a chat, and then are fine-tuned to also output code, right? So are these the same compatible models, or are they completely different things, right? So there is a lot to be developed in terms of model management, model versioning in the ML world. So we can, from a software engineering perspective, be able to get a new update and be confident that things are working even after testing, right? Well, another point I wanted to make, maybe I think one of the final ones is on the vulnerability side. Let's look at the time. Well, I don't have the time. Yeah, okay, we're still on track. It's very known that, you know, the dependency management is a source, or open source we use, a source of vulnerability problems, because very common the libraries we use have vulnerabilities in them. Right. So a study we did, we found, you know, things are not great because it takes many years for you to identify vulnerability. And even after it's published, everyone knows that the package has a vulnerability. It takes 7 months on average for the clients to update to a different version. That's a very long time that vulnerability could be exploited. But we have a process, right? We have Sneak, we have databases and everything on the sorts. On the AI world, this is very recent. So that I kind of found out when preparing for this presentation, they started cataloging the LLM vulnerabilities that they are finding. And we have all sorts of different LLMs, but you don't have a process to identify whether the model you're using have certain vulnerabilities. If you use a proprietary model like GPT, that model has been updated many times without you knowing. But the GPT-4 is not the same GPT-4 of 3 months ago, right? So it's very hard to trace, is your application affected by this? And we have all sorts of different vulnerabilities. There's a very interesting paper called "The LLMs Are Too Smart to Be Safe," in which they found out that they can tweak and they can trick the LLM into giving access to sensitive information. Just because LLM is this large language model that you can use ciphers, you can use things to trick into doing things it should not do, right? And one final thing, final piece of my talk is operations, right? And I remember Sylvie mentioned this back in the day as well. So DevOps is a practice that, you know, many of our industries are well consolidated with. Some of them, even large financial companies. This is a study we did that they had problems in adopting certain DevOps practices, and they use gamification, badges, systems to accelerate the adoption, which was quite successful. The problem is now, and then you have hundreds of tools for DevOps, right? All of those tools are meant to automate a certain part. We have a lot of things to choose from, which can be very good and very daunting at the same time, but we have tools and we have solutions. So a final sort of nail in the coffin is that while we have DevOps for traditional software, for ML systems, we have DataOps, and then we may have MLOps. More recently, we've seen LLMOps, right? All of those operations, they are usually managed by different teams. Sometimes they are managed by different companies altogether if you outsource the model training to a different company. Now imagine the burden of integrating this into your own system, right? So this is one of the biggest challenges I've seen companies do, is that they may have a DevOps well-structured, but their data is not versioned in the right way, or the models are not versioned in the right way, okay? And finally, I think that's something I found very curious. There's already a course on Google about LLMOps. I'm not sure how far they go into it. We know a few things about how LLMOps are maintained over time, but that's still very, it's emerging practices. There's a lot of quality concerns on that. Okay, so that's kind of the end of the second part, right? So I'm kind of pinching and sending you a lot of challenges, maybe a bit too much, maybe only questions, like, who's this guy just giving me problems, right? There's actually some good news to be mentioned, is that, of course, a lot of the papers I mentioned, these are done by the community. We have more and more emphasis and papers on the software engineering side are looking at the challenges of AI systems. So if you look at the ICSI, our flagship conference in software engineering, they already separated AI for SE and SE for AI. So there are different topics. Before they used to put it all together and sort of make it the same thing. It's not the same thing, right? So that means that there's a lot of smart people working on all of those problems I mentioned. But one thing I feel like is a bit overlooked is on the education part of it, right? And which is, I think we train our software engineers well, and we train our data scientists well, but sometimes I feel it's a lack of a bridge of communication between these two worlds. So we have an AI program and you have a software engineering program, but I think we should also include, courses and programs that combine the two. So our software engineering students can learn how to communicate with data scientists and understand the problems that come with bad data quality and everything that comes with this AI system sort of nightmare. That's it. That's just my usual outdated acknowledgement session because I haven't put some of the new students in there, but I will end up on this point. And I just want to re-emphasize the course that I gave at UCAM, the course that we have created for Concordia at the time. It's open source. There's a GitHub, everything's live materials. If you're looking for, being the one to sort of spearhead this at UCAM, at ETS, I encourage you to, reach out, look at the materials, ask us. We can give all the support that's needed. That's pretty much it. Sorry it took a bit too long, but I think it was worth it. Thank you.
Thank you very much. That was a great presentation.
Thank you. Thank you. It was
There's a lot of research topics all over.
It is a bit disorganized, but yeah, it's just kind of lifting the dirt in the air and hope people can sort of grab some of the projects and run with it.
Very stimulating.
Thank you. Yeah.
Large language models is kind of in the back burner because so much data that curated. Is data creation is done manually, or are there tools that just auto create data? Is that even something to do?
Yes. Yes. So if you have small amounts of data and the manual data curation is possible, in terms of large language models, they develop many different approaches. Right. One of them is that they use classifiers. They train classifiers to identify what is a good quality text versus a poor quality text. And then they train this by sending them manually curated, let's say, text from the New York Times, from reputable sources, academic papers, versus the rest of the internet, right, which could be unreasonable. The problem is that alone does not, block the LLM for hallucinating, right? It's a completely different thing. But they do classifier-based data curation, they do rule-based data curation. That means they assign specific sources to have a much higher weight in the training phase. Those are usually the two that I know of that it's employed. They are very rarely manual, to be honest. Any other question? I think we had plenty during, so. No, thank you all so much. I didn't quite check the chat on the, okay. There was no question. That's good.
Beaucoup de profondeur et beaucoup de.
Yeah.
Des sujets intéressants.
Oui, oui.
À la pointe de la nouveauté, des nouveaux.
Thank you. Yeah, it was a bit stressful because I started preparing. Just keep typing. It's like continuous delivery of calls. And now for Friday, I have to. No, thank you. Just in case.
And I told him you back.
Thank you, appreciate it.
Non, vraiment, c'est ce que je pense de toi.
Yeah, but I agree 100% with you. It's just
That you're bright.
no, that
Ah oui, merci à toi.
poorly defined terms. Like I started preparing yesterday, so I didn't have enough.